Morning, folks. It's good to see.
Morning,
looks
folks.
like we got a few audience members here. Hopefully,
it's good to see.
People are
morning,
realizing
folks.
how complicated this is, and you really need to pay attention and practice this stuff.
Hopefully,
so,
it's good to see.
You really should.
People are realize
folks.
how powerful
Audience
you
members
really
here.
need to pay attention.
Read the chapter,
practice.
so that you can get
Hopefully,
familiar with the
it's
terminology.
good to see.
You really should.
People are realize how
folks.
powerful audience members
really
here.
Also, I've got a bunch
pay
of
attention.
stuff going on.
I hope it won't interrupt
practice.
practice.
If it does,
Hopefully, it's
I
good to see. You really should. People are realize how powerful audience members here.
Also, I've got a bunch
pay
of
attention.
stuff going on.
I hope it won't interrupt practice.
Hopefully,
it's good to see. You really should. People are realize how powerful audience members here.
Also, I've got a bunch
pay
of stuff
attention.
going on. So, while we're
I hope it won't interrupt practice.
if you have
Hopefully,
any
it's good to see.
questions,
You really should. People are realize how powerful audience members here.
look at some examples that might help you in this. So, while we're
I hope it won't interrupt practice.
hopefully,
Hopefully, it's good to see. You really should. People are realize how powerful audience members here.
look at some examples that might help you in this.
I hope it won't interrupt practice. Hopefully, it's good to see. You really should. People are realize how powerful audience members here.
I think that's why everyone left. I hope I'm being I think that's why everyone left. Sorry, folks. Please say something in the chat if you're hearing a terrible sound right now. I don't know if it's just on my end. Okay. Seems like everything. Please say something in the chat if you're hearing a terrible sound right now. I don't know if it's just on my end. So, okay. I wonder. Seems like everything. Please. It's my audio here. Let's turn that off. Okay. Weird. I didn't change anything, so I don't know why I did that. Hopefully, you can hear me now. So again, if you're, I'll just repeat myself because who knows if you could hear that. Good morning, folks. We are talking about inheritance today and polymorphism in object-oriented programming. You know, this idea of object-oriented programming, it has a lot of pieces to it, and if you've only done procedural coding, it's hard to wrap your mind around it. And that's why, you know, it's in your second year. But this is what you'll be using most likely in your job, because using object-oriented programming helps make your code modular. It helps make it easier to maintain, easier to understand once you understand object-oriented programming, and it's also a lot more scalable. And by that I mean if you need to add things to it or adjust it, you can find what you need. Things are separated into categories here. Let's see. I don't want to see myself a million times. Okay, hopefully I didn't scare anyone off. I think right now I'm the only one watching myself here. Alright. Get the chat reset up. Alright. So the last thing we talked about here was this implicit reference conversions. Alright. And we talked about it, so you can take a look in the previous video. There is an idea that's important with this word reference, okay? And if you know, up until this point, I try to mention it in my other classes. The way objects are stored is by reference. So let me pull up a diagram here. We can make a quick diagram of this. So I have the diagram that we made last time. You can take a look at how we built this to help explain what we're doing. So I'm going to make a new one here. And we'll call it object reference. So if you've taken programming classes with me before, I try to say this at least once. I like to show people this because it's kind of like a trick question, and it kind of illuminates the fact that you need to understand what's happening in the background, and so your knowledge of how a computer works is important, especially because you're going to be, part of your job is going to be optimizing efficiency, and if you don't know how the computer, I mean, that's the physical part that everything runs on. And so anyway, we're going to talk about references and values. All right, so inside the computer we have the three main parts. We have a CPU, and we have memory, and I'll use this, and for memory let's use it doesn't really matter, we'll use a card, whatever that is. Okay. And I think I double clicked on it. Okay, good. So here we'll have the hard drive. So that's your persistent storage. All right. The CPU. This is what processes all the instructions. And this is a very simplified view. There are a lot of other layers and complexities here, but just for this example, we need to see how this works. All right. So when your program is running, it's using the computer's memory, and that is what we need to talk about. Okay. Put a little thing here. So some of you guys build your own computers. So this is the RAM, is the physical component, but for programming, the memory is where we store everything that we need to use, all right, or the program needs to use. So values, objects, anything, if you have an application running, that's running in memory. And the reason that is, and the reason we're storing stuff in the memory is it's much faster than the hard drive. Okay, so hard disk drives have a metal platter, and it has an arm that magnetizes spots on the platter. That's how it is persistent. The data is persistent, so it doesn't go away when you turn the computer off. All right. the CPU can store values, but it's very limited because the goal is to get what you need in, process it, and spit it out. This is, a very fast part of the computer. It doesn't have moving parts. It's just circuitry. And so it can go as fast as, or it can send signals as fast as you can send electricity through a wire. And the presence of that electricity inside of the CPU is stored in, I'm not an expert on electronics, but this is how I understand it. It's stored in transistors, which require a constant supply of electricity to maintain their state of either having having a charge or not having a charge. Okay, the way that memory stores data is similar. It's all circuitry, and so that makes it much faster than the hard drive. So the hard drive is, or at least a hard disk drive is slow because of the moving parts. And someone asked in another class what the difference is between a hard disk drive and a solid state drive. And so I looked it up just enough to get a basic idea, because you should be interested in how a computer works if this is going to be your field, and keep track of the latest technologies, because it's always changing. So anyway, a hard disk drive has moving parts. That makes it slow because it actually has to follow the rules of physics in terms of moving things. And so you have to take my word for it. Electricity moving through a wire is much faster than anything physical can move, that I know of anyway. Okay, I think I've heard it described as the speed of light minus the resistance of electricity traveling through copper wire. So that sounds, I don't know. Someone fact check that for me. All right. The whole point is it's fast. Anyway, a solid state drive, as I understand, also uses circuitry to store data, but it doesn't use a type of electronic component that stores an electric charge. Instead, someone figured out a way to manipulate the atoms or protons or something. I'll have to look it up again, so that you can detect whether it's in one state or the other. And why is that useful? Well, everything's stored as binary, on or off in the computer. And so anyway, you can store data by manipulating these structures. They don't require a constant electric charge to maintain that state. Okay. The downside is, at least as I've in my personal research have seen, limited. The solid state drive, the way it stores things, is limited in the number of times you can write to it. So if you are adding a lot of files, deleting them, and overwriting them, it could wear out. I'm not sure if, supposedly it wears out faster than a hard disk drive. And so a solid state drive is much faster than a hard disk drive because it doesn't have the moving parts, but the way it stores the persistent data physically, you want to limit the amount of writes to it, so storing data in it. Every time you store data, it is using up, whatever, how would I describe it? The durability, or it can only be used so many times. Okay. So if we want computers to be fast, and when solid state drives came out, they were very expensive. Now they're fairly cheap. And so you're probably going to have, most computers are going to use them. And so if the issue is limited ability to write things to the hard drive, it'll be a good idea to be more efficient, limit your access to the database. The database would be on the hard drive, or stored on the hard drive. That's where everything's stored. If you want it to exist after you turn the computer off. But this is a big enough difference to understand, we already wanted to limit access to the need to access the hard drive because it's the slowest part. But keep in mind, everything that's being done in memory is temporary unless we store it to the hard drive. As soon as this is why when you open Microsoft Word and you type a paper and the power goes out, the paper is gone, because it was only stored in as electrical signals in the memory. And so once that signal gets cut off, it can't be refreshed, everything dissipates, and your paper is gone. We don't have to worry about that as much now with cloud storage, but everything gets auto-saved. Kind of like when we use Replit. Every time you type a character, it's storing it on their servers, and then when you want to access it, it's going to be there. The only downside to that is you got to have an internet connection to use it, to access your data and to save things. All right, anyway, given a broad overview of, this is background. Grace is a good question. This is background information that is going to help with Chapter 10, because I'm not sure if everyone has had a class with me. I tend to talk about this in every class because we have a hardware class, but I don't think they cover this, and I don't want you to be ignorant of the fact of how a computer works if I can help it. All right. You need to know how the memory works, because that's where we're creating objects, and those objects are stored in memory. And we need to understand that a variable is not, when we create an object and assign it to a variable, we're not assigning the actual value in the object to the variable. We're assigning a reference that points to that object in memory. Okay, so we'll describe what's happening here. We got creating an object. Remember, that's the keyword new. So this creates the object in memory, returns the reference. So when I say reference, we're talking about the memory address of where that object starts. So the computer knows, because of the class and all the properties and methods we defined, how much space in memory that object is going to need. So our reference only needs to tell, or only needs to store where that object starts, and it will know when it ends, because we have a definition for that class that it uses. So if it takes up multiple spaces in memory, it'll know how many. We don't have to worry about that. Okay. Returns the reference to the object in memory. Okay, so let's say we're writing our code in C#. For example, in the conference assignment, it asks you to generate 5 conference objects and store them in an array or a list. And so when you created those objects, you use the new keyword. And what that does is it finds the space, and this is all managed by, I believe, the operating system. It's been a while since I took that class. All right, so here's our object. And remember, an object is an instance of a class. So this is going to take up space in memory. So, you know, if we create a conference object and we have different fields in there that we store information about, I think you had to store the name and the date and how many attendees there were. That gets created in memory. All right, and then, you know, if you, as you are giving the input, it's creating that object. All right, give me 1 second here. No, it's fine.
They made the new one a little too long for my bed, otherwise I can't close my tonneau cover.
Yeah, you don't have to line out your
Right, yeah. Yeah, this is so cool, right? That, yeah, I agree. It is very neat. Do you
I'm
want
just
me to put a mask on?
Oh, if you're comfortable Testing, testing. Oops, not that one. This one. Deactivate. Activate. There it is. Okay, cool. Make sure it's streaming. Get the chat set up. I'm definitely going to have to edit this video someday. Okay. Sorry about the wait, folks. If you need to go because it's cutting into your other classes or anything you had planned, you know, these are optional and you can always watch the recording later. Okay. So, just to catch up for a second here. We were, I was explaining the difference between storing values in a variable and storing a reference to an object in a variable. So when you create a new object, it gets added to memory, and inside the memory there are locations that can be referenced. So this is a super simplified version because there's a lot more spots in this. And the operating system handles this for you, so it's not like you're going to have to pick the spots. You used to have to do that, or you could do that in C++. There's probably a way to do it, but that's really advanced. You know, when you're designing something that no one has done before and you need capabilities that people didn't consider, you may have to work on that kind of stuff, but like I said, it's fairly advanced. So I'll put address. It's much too big. Address. Oh, that's much too small. We want just right. Okay. I'll just call them spot. No, let's call them address because that's the proper way to refer to them. So address 0. Okay. And I think I can just grab this and we'll shrink this down. You know, I use these diagrams because it is helpful to be able to visualize what's going on, and it just makes it easier to understand. Okay, we'll put this here, here, and here. And we'll call these object 1 and object 2. Alright. And this will be address 1, 2, and 3. Okay. So, this is what a memory address actually looks like. Right here. This is what I'm trying to draw, but a simplified version. Okay, so this is an example of values being stored in a memory address. And so here is binary. These are most likely binary representations of numbers, because that's how it is represented inside the computer. And so, you know, you can convert these to decimal numbers to see what's in there. Okay. And so let's, I'll make a little simple example here. And if anything isn't making sense, remember you can ask questions. Oops. All right. Let me double check that it's not doing that terrible sound again here. Okay, we're good. I don't want to burn out your eardrums here. Okay. So, you know, we can declare a variable. Int num equals 1. Okay, we can declare a string word equals hello. All right. Now these lines are creating a variable, and inside that variable we are storing a value. Why is that significant? Well, let's take a look. If we console dot write line, not console, just write line here. Trying to keep all my languages straight. And we just want to print out the value in num. All right, why am I spacing on this? It was literally right there. Is it console? Yeah, it is console. Okay. If we wanted to print out in the console, we got to reference the console object. All right. So this prints out 1. Okay. Zoom in here so you can see that. It prints out 1. All right. We can change the value in that variable, so we could do num plus plus, and then console.writeLine num. What do you think it'll be? Remember, this is the increment operator. Let's see. So it should print out 1 here and 2 here. All right. What if we create a new int variable called num2, and we set it equal to num, and then if we print out num and num2, we'll do this. So num, we'll put num is num, num2 is num2. Okay. Put a little line break there. And run it. Is there a shortcut to run it in here? Oh, that's refresh. That's not what we want. This would help me a lot while I'm zoomed in. So applet shortcut for run. Control enter. Okay, that's good to know. So we do control enter. Okay, num is 2 and num2 is 2, right? Because we started with 1, we incremented it to 2 here, and then down here we're just taking the value in num and copying it into num2. Copying that value. So inside of num we have the value of 2, inside of num2 we have the value of 2. If we increment num1 again, or num, what will the value of num be? This is simple because we need a baseline of understanding what's going on. This is something you should understand from all the classes, creating variables and manipulating the values. All right, and we'll do this again because we're going to need some labels on this. It's going to get confusing. Num is num. So our last thing here is num is 3. And what will the value, if I print out the value of num2, what will that be? I'm going to put a little divider here so it doesn't get as confusing. No, what line? Line 20. Did I forget to finish? Line 20. Oh, 20. Oh, I just forgot my. Oh, it added a double quote. It was trying to help, but it messed everything up. Okay, so Control Enter. So num is 2, num2 is 2, and then we add one more to num, that changes it to 3. It does not affect num2. And you might say, okay, duh, that's common sense. But let's take a look at what happens to objects. And you can, if you know what's going to happen, or if you have a guess, just post it in the chat. What we're going to do is create a class here, a very simple one. We are going to create an instance of that class, that's an object, and store it in a variable. And then we are going to assign the value in that variable to another variable. And then we are going to print them out. We're going to manipulate them and print them out and see what happens. Okay, so generally, you would create classes in another file, but for the sake of not having this, being able to see the code altogether, we're going to do it this way. Oops. Class banana. Let's make it a public class. Public class banana, and we'll just give it a couple fields here. Let's go color. So that's going to be a string. Color. Remember, fields need to be capitalized. And we'll set the get, set, and we'll do the same thing for, let's do weight. So this will be an int, weight. See if I remember the syntax correctly. All right, I did. Okay. So we have this stuff is showing us variables that have a value. So we're going to take this and comment it out for now, so we can see when we use objects what happens. Remember that the idea here is for you to understand when you create an object, where is that? What gets stored in a variable when you assign an object to a variable? And what are the ramifications of that, and what can you do and what can't you do with it? And if you don't understand this, you want to. This is extremely important for any programming, because if you don't understand it, there are a lot of mistakes you can make that just won't make any sense. Logical errors. So you can make syntax errors, you can make logic errors. Syntax errors are, you just made a mistake in the grammar of the code, and in C#, it just won't compile. It tells you what the error is, so you can't even run it. A logic error is it runs, and, something is wrong. It's not working the way you intended, because you told the computer to do something different than what you intended. Okay. And most of those are caused by not understanding what you can do. You don't have those basic skills. So anyway, we're here to learn those. So let's take a look. If I want to create a new object, I use the name of the class. And so it's going to be type banana, and we'll call this one fruit1 equals, and we're going to create a new instance of the class called an object, new banana, and we'll call it the default constructor. So remember, if you have parentheses after an identifier like this is the class name. You have parentheses after it, that it means it's a method. We didn't define any methods in here, but C# will give a class something called the default constructor. So here we can call this to set up a banana. Since we don't have any values in there, we'll have to manually add those. So we can do fruit1.color equals, and we're only able to do this because we set these up as properties and we put default getters and setters. That allows us to pull the value out by referencing the field, or sorry, I'm going to keep messing this up, by accessing the property, and that in turn accesses the field. But so get allows us to pull the information out, set allows us to change it. So if we just do this, fruit1.color, it's going to call that, it's going to call the setter, because we're assigning a value, and why not yellow, right? Don't forget your semicolons. Alright, and if we print this out, okay, so we'll do fruit1 is fruit1.color, and weighs fruit1.weight. Color and weight. And we better set a weight here so we don't get any errors. Yeah. Because when you try to access this and it has no value, let's see what that does. It's good to see errors, so that once you recognize the errors, are able to understand them, you'll be much faster at programming and debugging. So let's shortcut is Control Enter. Let's see if I made any mistakes. All right. Oh, I didn't make the fields public, so that means outside this class they can't be accessed. So I better do that. So here it says it is inaccessible due to its protection level. If you don't provide a protection level or an access modifier like public, then it uses, I believe it just uses the most strict modifier, which for now we've used private and public, and we talked about protected, so those are our modifiers. So I believe it sets it to private, but since we're talking about it, let's go check. And if you don't understand an error, don't just go to the line and use trial and error to fix it. Google the error, because you have to learn to understand these errors. So trying to figure out what this is. I wonder if this is an error code. Anyway, let's look up error CS0122. Okay, didn't copy. I think you might have to manually do that. I'm not sure if I just hit the wrong key or what. Anyway, we got it now. The CS0122 error is caused when a member without the public access modifier applied is invoked, which means you are trying to access it or basically use it. When we talk about methods, I usually say run the method or call the method. Invoke is also a term that you'll see here, a more technical term for it. Okay. In this example, we've created a private method and attempted to invoke it after checking the value of a private variable. So it's exactly the problem that we had. All right, and what other errors? They were all those errors. And it's because I did not set the members to public. All right, let's look at default access modifier C#. Internal is the default if no access modifier is specified. So let's double check that. Internal, the type member can be accessed by any code in the same assembly, but not from another assembly. So in this case, we have the banana class and the main class, and there's nothing that connects them together. So to be able to access things inside here, they need to be public. Okay, anyway, that should fix that. Okay, fruit one is yellow and weighs 0. We didn't set a value there, I don't think. So it looks like it's defaulting to 0, which is interesting to me. Let's see if we don't set a color. I wonder if it would use the empty string. Control Enter. Yeah, it looks like it's just using the empty string. Okay. So if we don't provide values, it looks like it uses some default value. For an int, it looks like 0. For a string, empty string. So we want fruit one.weight equals 16. We'll say maybe ounces. I don't know what, if that's a big banana or a small one, but it'll be 16 units of whatever is fine, since we didn't specify. Okay. And so now if we print that out, we'll be able to see those. So this is all just set up for the example. Unexpected symbol console. I can tell, so this is an easy one to fix. I probably forgot a parenthesis. Yeah, you're not going to be able to press Control C in here. You're going to have to right click. Actually, let me try Control Shift C. Nope. Okay. Yeah. So you'll have to select it over here, right click, copy, paste in the error. This is caused when an invalid character is found in an expression. For example, the if statement below does not allow the symbol a to appear after if in the if statement. Okay, so here's their code example. What are they missing here? They're missing the opening parenthesis. So it's confused about the grammar you're using. This is improper programming C# grammar. Okay, let me close some of these so I don't get lost. All right. So it says line 26, we made a grammar mistake. And it's because Oh, if you have an error on the line, you know, I could pour through this and try to guess what's wrong, but the problem isn't actually on this line, and sometimes you won't be able to find the error on that line. Here it says unexpected symbol console, which means console in terms of the grammar of C# is in the wrong place. I don't see any problems with where it is, but I did make a mistake. It's the same mistake I keep making every time. And what you do is you look backwards from the mistake, because the code runs from top to bottom. Pulling you know, methods from classes and things. So we should start looking backwards. So let's look at the line before. Oh, there's an error. I forgot to print a semicolon right there. Even though it said the error was on line 26, that's because that's when the computer stopped understanding what you wrote. All right. And so if you remember anything for debugging, remember you don't need to look forward, you need to look backward in the code to find errors if you can't find it on your line. Okay. And Google these codes, because you'll find a much better explanation than what they've written in here. Once you see these enough and work with this enough, they'll become second nature to you. We're not going to memorize them in class because it doesn't mean anything if you don't have the context. Okay. So fruit 1 is yellow and weighs 16. Let's create another one. And we will call it fruit 2. And instead of creating a new object, we'll use fruit 1. All right. And we can see if we print out the values in fruit 2, what do you think they'll be? Forgot to update the label here. Okay. So it says fruit 1, yellow 16, fruit 2, yellow 16, right? So what's happening here? With only this much, we might assume, you know, now fruit 1 and fruit 2, you know, have the same values in the object. All right. Well, let's say we don't want fruit 2 to have the same values as fruit 1. So let's go and get the code here, and we'll use it to change the properties of fruit 2. Okay. So we're printing out, you know, when we create it, and then we're printing out, and then down here we're going to change the properties and then print it out again. So maybe this banana isn't ripe. It's 16 or green, and it weighs 4. It's a tiny banana. Okay, and then we'll print that out. Oh, I didn't. Okay, I didn't actually change these. Let me run it again so you can see. It's going to be the same. All right. Fruit 1 is yellow 16. Fruit 2 is yellow 16. When you're copying and pasting, make sure you change your references. Make sure they're. It's going to cause a lot of problems if you don't. So you need. Part of this job is really good attention to detail. And some people have that naturally. Some people don't. It's something you. If you like programming, you will form it. You will form good attention to detail as a skill. Or you'll just get so aggravated you don't want to do it. But that's part of going to school and learning this stuff, especially at a community college. You know, there's not as much you're not risking as much by taking the classes here. So it can help you determine, do you really want to do this? If you are spending every day working on this stuff, you're probably in the right area. If you get aggravated and you can't work on it, then you're probably in the wrong area. And your instinct should be, if you get aggravated, to ask me, because you're probably just missing a key piece of information, okay? You will get aggravated a lot when programming. Taking a break's a good idea. All right. So let's make sure we're changing fruit too, after I just made a big deal about that. All right. And guys, feel free to post anything in the chat if you want to ask questions. Okay. And so let's print out fruit 2 down here. And what do you think it'll be? It should say fruit 2 is green and 4, right? Well, let's see. Fruit 2 is green and weighs 4. Okay. Let's print out fruit 1 again. Why would we do that? We haven't changed it, right? So it should, what do you think it'll be? Based on the patterns we've seen here. Okay, so we'll go back and print fruit 1. So fruit 1.color, fruit 1.weight. So think about, this is the trick part, that if you don't understand how things work, it's not going to make any sense. Okay, let's run it. So fruit 1 is yellow 16. We assigned the value in fruit 1 to the variable fruit 2 and printed fruit 2 out, and so they have the same values. We changed fruit 2's values to green and 4, and then we printed it out, and then we went back and printed out fruit 1. And what do you notice about this? Is it what you expected? Let me label this because it may be hard to follow in the output. So here we'll put assigned values to fruit 1. New line, put some asterisks in there. Okay. Oops, we want this part. Let me see how that looks. So we assign values to fruit 1. More accurately, we can say assigned values to fruit 1's properties. Let's be specific here. I'm going to be using the terminology probably more a lot because you need to be comfortable with it. You know, I don't want you calling things, you know, use the squiggly line. You know, it's hard to think of. Usually you guys just don't even say anything, so you don't have any practice talking about this stuff. Some of you do, though. Some of you use the terminology. If you don't use it, you know, I'll try to correct you because you have to learn what things are called in any kind of technical field. All right. So that looks, no, I need this, \n. There we go. And we will copy this down into each print, so that way we know what's happening. So here, for this one, we assigned value of fruit 1 variable to fruit 2 variable. Okay. Okay. So step 1 here, we assign the values to fruit1's properties. Here's what it looks like when we print it out. And then we assign the value of fruit1 variable to fruit2 variable. Fruit2, and when we print it out, has the same values. And what did we do next? We changed fruit2's properties. Changed the properties of fruit2. Is giving me a problem here. Well, oh, there it goes. It was just slow. Okay, so there we changed the properties of fruit2. And then we say down here, this is a question that after this demonstration you should be able to answer, and it's something you need to remember. It's very important. Have I made that clear? To understand what's going on in object-oriented programming, you have to know this. And it's important in any case where you are using object-oriented program, not only in C#, because you may have to use Java in your job, which is easy to learn if you know C#. You can use objects in JavaScript, you can use objects in Python, though it's kind of weird. Anyway, why does fruit1 change? Let's see, why does fruit1's properties change? So if you're watching this right now, what is your best guess as to why that is? We didn't change the properties explicitly in this code, right? There's no lines of code that say fruit1.color and fruit1.weight are green and 4, but when we print it out, they are green and 4. Back to the diagram and we'll explain it there. Okay, so remember what I said. In the memory, when you create an object, it creates an instance of a class. We call that an object. And the actual variables, so we were creating object 1 and object 2. Object 1 is in memory spot 0, object 2 is in 1. Again, this is simplified just to illustrate what's going on. Okay, so let's say let me see if I can put this side by side so we can see the line of code and what it's doing. Okay, so up here, when we declare a variable and assign a value, this is considered an integer. It's a primitive value. We can represent that directly with binary. You can represent, any decimal number with binary. I think it was this class last time we looked at the range of the numbers that you can use, which was some like, we looked at the range of 64-bit numbers. I think it was this class. If not, you can just Google 64-bit numbers and it shows you, or 64-bit signed integers, and it will show you the limits. So if you try to store a number higher than the limit, it will give you an error, and the number's so large in most applications you're not going to need to worry about it. Anyway, it's storing the value in the variable. If I assign that value to another variable, like we did here on line 14, we took the value in num and we assigned it into num2. You can describe this as assigning by value. So the computer checks the value in num1 and copies it into num2. So now there are two variables. They have the same value currently, and then we changed one and it didn't affect the other one because they're considered two different things. When you create a variable that is in memory, but what's stored for that variable is the actual value. Okay. When you create an object, remember we have to use this new keyword. When you do that, the computer stores into the memory the object, the information for the object. And so, we created an empty banana on line 22. So let me change the name here. We stored it in a variable called fruit1. All right, and then what else did we do here? Okay, we created a new object, and we're assigning the whatever this returns into fruit1. So what that returns is the memory address of the banana object. Okay. This is something that if you're going for an internship or entry-level position, that is a really good way to suss out people that have no idea what they're doing. And so I'm trying to tell you this is extremely important. If you don't know it, it could prevent you from getting a job. Plus, you wouldn't be able to do the job if you didn't know this. All right, let's make it readable, but fit it into here better. Okay. Part of it's floating outside of memory. That's okay. Okay, and then we created another banana object down here. Oh no, we didn't. We did not create a new banana, and the reason we know that is because we didn't use the new keyword. So unless you use the new keyword, you're not creating another object. But what we are doing is creating another variable, and then we're assigning the value of fruit1 into that variable. So let's say variable, and it'll be easier if I just copy the lower one here. So we have the variable fruit 1, when we created that and assigned the value from creating a banana object, is the memory address of the banana object. Okay, and so what that would look like is address 0. That is the value that is actually stored in the variable. The object itself is not stored in there. The reference to where the object is in memory is stored inside of there. All right, and it's easy to use objects without realizing this, okay, while we're learning. And you could probably get by without knowing it, but you're not going to be able to progress or you're not going to be able to do a very good job. So that's why I'm really harping on this. Okay, so we got to talk about it eventually. Okay, so when we created fruit 2, and if anyone's watching, or if you're watching this as a recording, pause the video after I ask this question. And so you can think about it, what value is being stored on line 28? We're taking the value in the fruit 1 variable, and we are assigning it to the fruit 2 variable. Okay, so it's copying the value from one of the variables to another. So what's stored in fruit 1? Well, it's the address to the object we created. Address 0. So now what we have is 2 variables that reference the same object. And that's why when we change the properties of fruit 2, what's happening is the computer says, okay, fruit 2, that's an address to an object, and it will actually find that object, and then we put dot color, it'll check that property for that. And so all this is a reference to that this right here, fruit 2.color, is referencing the property of this one object we've created. Okay, if we change things in fruit 1, it's changing the same object, right? Let's stick it up here. All right, so at this point, both the variables are pointing at the same object. If we want 2 different objects that have independent values, we just need to use the keyword. So instead of assigning the reference from fruit 1 into fruit 2 and having 2 references to the same object, we would just have to create a new object with using the new keyword. All right, now what happens if and I'm not going to demonstrate this one because we need to move on, but assume I create a new banana object, okay, and it would be assigned in memory, the values of the fields and everything, the members and everything would be in memory here. And then I assigned I put it in fruit 2. Well, it doesn't take that long to do this, so thank you, Nate.
No problem. They just dropped it off at our house.
Yeah, they must have been in a hurry. So let's say we create a new banana object using the new keyword. This is important too. Alright. So down here, we will create a new banana object and we'll set it to blue 100. This is an alien banana, I guess. Okay, make sure there's no errors. And I closed the console, so we need to get that back. Okay, a local variable named fruit1 is already defined in this scope. Oh, right. We already declared the type of the variable, so we don't need to declare it again, right? Let's see, and what error code was that? That was... This message is, well, I don't know. It maybe, see, it's hard for me to relate sometimes, so I'm trying to, bring things down to the level where you'll be able to understand it with having limited knowledge of this, right? That's my job as a teacher. Okay, it says error O128. Copy that. It says a local variable named fruit1 is already defined in the scope. And so, I've seen this error before, I knew right away what it was talking about. But if you get an error where you don't know and you can't interpret it, remember, you just Google it. Alright, compiler error, CSO128. The compiler detected declarations of two variables with the same name. So when you declare a variable, you're reserving that name. It can't be declared again within that scope. And so I'm declaring it within the main method of the main class. So within the main method of the main class, I cannot declare another variable named fruit1. All right, so back to the code. Not that one, this one. Okay. Let me know in the chat if, or message me or leave a comment if you already do this for your debugging. Proper debugging is, here in the class, especially when you're starting out, you just use, I know you guys do this, you just use trial and error to figure things out. And in the beginning, you don't really have much other option, but I'm trying to show you techniques that'll save you time, because debugging is a huge part of developing. Though the mistakes that I've made in here and that we've looked up are just syntax mistakes. If you use this every day, that you won't even be making those mistakes eventually. Usually I get more complicated mistakes when I'm doing something in whatever language I'm using, when I'm doing something I haven't done before. Okay. So we created a new banana and we stored that in fruit1. So in our example here, we would have another banana object. Okay, and as far as the computer is concerned, these are both banana objects, and the only way you can reference them is by the reference in the variable. So we assign the new one to variable fruit1. What's that going to do? It's going to change the value in there to the address of the new banana object. So now this is address 3. It's no longer pointing at the first banana object, it's pointing at the new one. Alright. This thing isn't always perfect. Okay. So we have fruit 2. It's still pointing at the first banana object. Fruit 1 is now pointing at the new one. All right. What if I do this? Fruit 2, we're going to assign the value of fruit 1. All right, so think about what that would do, because we've already seen that on line 28 up here. We're assigning the value that's in fruit 1 into fruit 2. And we know, we just talked about this. The values in here are the memory addresses of the objects. So what's happening on line 43 here? Well, we're just taking the value in fruit 1 and we're putting it in fruit 2. So that would copy the value here, which is address 3, into fruit 2. Okay, and again, that would no longer be pointing at the first banana object, but now it is pointing at the second. So look at, this is what's happened, and by what we did in the code, and we can see it should work unless I made some syntax errors. Control Enter. Yeah, no errors. Everything's fine because we're not printing anything out from this. What if we want to access the first banana object we created again? How would we do that? How do we know what the address is, right? Because in the memory we only have 2 variables that point at the new banana object. Nothing is pointing back to the first. So we've effectively lost this object by doing this. Sometimes you want to do that, sometimes you don't. But if you don't understand this, this is a problem you could run into. So now we have 2 references to the new banana object, no references to the first one. You can effectively think of it as being gone. Now what's really happening in the background is the computer will find, and it's called a garbage collector. So we can look up C# garbage collector. Because if we have an object with no reference to it, we're never going to be able to use that again. So it frees up that space. All right. This is another question that you might get in an interview. And this is a course that you take in your 2nd year. So every semester, I try to get closer to what you're going to be doing on the job and talking about what you might encounter in a job interview. And this is something that if you took a programming class out of a textbook, there may be a blurb or a paragraph about it, and you may not be able to understand what's going on. Okay, so the garbage collector serves as an automatic memory manager. All right, so remember we have this object in memory, no reference to it, so it's taking up that space. Okay. The garbage collector manages the allocation and release of memory for an application. So this doesn't have a reference anymore. The garbage collector should find it and release that address for use again. Okay, and so in the past, programming is getting easier. I don't know if you believe that or not. In the past, you would have to write your own code to do memory management. If you've ever heard of the term memory leak, if we didn't have a garbage collector in C#, all the space would eventually get taken up by garbage. And so a bunch of memory would be blocked, and then your computer may need to rely on virtual memory, which is where it uses the hard drive as memory. And earlier we talked about the hard drive is the slowest part. Memory is faster, the CPU is faster, by a lot. If you're using the hard drive as virtual memory, your computer is going to slow down a lot. Okay, so, and it may even lock up. So it may slow down to an unusable state. So to prevent that, we have a garbage collector. But in the past, you would have to manage it yourself. Some people still use programming languages where you can manage the memory, like C++, because the default memory management may not be efficient enough to do what they want. So again, I feel like I'm repeating myself from a previous class, but we can use C++ as an example that's still used in game development. So you may try to be creating a game and you want to show 1 million enemies on the screen. All right, that's going to take an immense amount of memory, and so the default way memory is handled, let's say it only lets you show 100 enemies on the screen and keep track of them. Well, you could write some sort of memory management that would use the memory in a way that it wasn't intended to achieve something like that. So there are strengths to that, but in what we're going to be doing, unless you move up to like a software architect, or you are doing development outside of business, you probably can just rely on, and it's much more efficient now. It's always becoming more efficient. It's kind of hard to, I think, in Windows 10, it's kind of hard to create something more efficient than the memory management defaults. Okay, and we don't have to worry about that. But it's good to know that it exists. And so, for example, if you were going for a job where they wanted you to use JavaScript, C#, what other language? Well, let's just say those two. And they ask you a question about memory allocation, or they ask you about garbage collection. There may be, if you know the differences between the two, that would be very impressive. If you know what garbage collection is, at least at a minimum, then they know you would be able to look it up. So we will be using JavaScript and C# in the capstone course. So let's look up JavaScript garbage collection. All right, and we can see what the differences are. So hopefully you guys remember what a local variable is. Local variables lose their references when the method is finished, or the function. So it says local variables and parameters of the current function. Here they're saying those won't be deleted. Variables and parameters for other functions on the current chain of nested calls. Okay, that's something we're going to need to talk about eventually, but I want to finish chapter 10 today. Let me see here. I want to make sure I'm taking a long time here, but I want to make sure I'm not booting anyone out of their appointment with me. When I'm teaching a class, everything else kind of fades away, so this is the 22nd. Yeah, okay. We're good. I could talk all day. I'm not going to, but again, if this is going too long for you or you need a break, you can always come back and watch the rest. Okay. All right, so hopefully this gives you some insight to what's happening, and I want to stop talking about it because we'll end up talking about how everything works, which eventually you'll need to know, but some of this you'll just have to figure out on your own, okay? So anyway, the important thing here is garbage collection, finds, variables, and, well, basically variables with identifiers, that are unreachable, which means you would never be able to reference them again. Same with objects, like we did here. You would never be able to get back to this object that has no reference now. So the computer would detect that and get rid of it. Okay. And by doing this, you're telling it to get rid of it. I believe you can explicitly tell it to do this too, so you don't have to wait for the garbage collection, which can help with, memory leaks. So a memory leak, again, is you're just the memory is full of junk you don't need anymore. Easy to avoid by not creating situations where you're going to have unused memory. Okay. So let's get back to this. So the two things, there's a few things I want to talk about here. But the two things that you need for the assignment are abstract classes and interfaces. So we're going to look at how to create an abstract class and why we would do that, and how to create interfaces, and again, why would we do that. So we've already used one interface, the iComparable interface, which allows things like lists and arrays to compare items within the structure, within the array, or within the list against each other for the purpose of sorting. At least that's what we used it for. Okay, let's go back to the diagram I was working on last time. I'll save this one because I don't think we'll need it again for today. Yes, overwrite. Okay. Let's go back to the previous diagram here. So things like garbage collection, that's something that you should really, other than what I just said, I don't know if we'll talk about it again. That's something you need to research on your own. There's a ton of things, there's way too much to learn in 2 years, just in the class. So you should be doing stuff. If you're serious about getting a job in this field, you need to be doing research and practicing constantly outside of class. The more you do, the easier it'll be to get hired. Okay. All right, I'm looking for the diagram. Here we go. So last time we talked about inheritance and extending classes because we're focused on learning polymorphism in object-oriented programming. And one of the big reasons we do this is so that we don't have to repeat ourselves, because when we have to repeat ourselves in the code, if we have to change it later, we'll have to change all those spots, and then maybe you'll forget a spot and it'll break everything. We're trying to centralize the code so it doesn't have to be repeated again. All right. So one way we did that was by extending creating child classes from existing classes. Okay, so if you find an object or are using an object but it doesn't do exactly what you need, but it does a lot of stuff you need, you can extend it. It'll have all the capabilities and properties of its ancestor. You can, if those are virtual, we talked about overriding the methods. So if you forgot about that, check out the last video again, because we're moving on to abstract classes. Though there is one thing I want to touch on before we do that. And hopefully it won't put me down a path of talking about a million things for a couple hours. Okay. So let's pull up our last example here that we were doing. So I don't have to retype everything. You guys don't have to wait. All right, what were we using? C#. I'm looking for 7 days ago. So it's back here. Here we go. I don't know why I made a copy of it, but it should work. All right, so to basically help you with the conference assignment, we created this example where we were creating a board game, and using a board game class, and we have, what properties do we have? Let's see, I usually put the class at the bottom here. So in some languages, you have to define methods before you use them, and even classes. In C#, I believe the compiler does a double pass. I might need to double check that. And so it'll check the signatures and then go back through to make sure if you reference something before you have actually created it in the code anyway, which creates kind of a independence of how you want to organize your code. You still can't use a local variable before you declare it, but larger structures, you know, let's see. The program ran here and we had the class defined after. Okay, let me get back down to the class. Here it is. Nope. Where is it? Wait, now I don't see. Oh, wow. I created it in a separate file. Right. All right, so then, you know, where is it in comparison to the code in main.cs? Well, it doesn't matter because of the way C# compiles. Okay, so in the class we have name, players, rating. And I don't think, for this one we didn't print out. Let me copy this. So you can fork it and that makes a copy. And this one will be object to string method. So in our diagram, if you remember, the classes that we create inherit from the object class. It has a bunch of kind of base useful methods in it that you can use. All right, so things like get type, which returns the name of the class. ToString, which is the one I'm going to show you an example of. This basically, when you try to print an object, you can control what it prints out by using this. The equals method, which is used to check, here it says, and this is what we were just talking about, returns true if two objects have the same memory address. So when you're working with more complicated code, there may be situations where you need to double check that references are either equal to the same object or not, and so you would use the equals method. Alright, it says you should override this method in your own class. Let's not worry about that. This one can be fairly complicated. Override. Okay, well, we'll try it maybe and see if it works anyway. Okay, and there's the get hash code method. So when you create an object, it does have a unique number assigned to it. Okay, we're not going to worry about that. Did you ever use get hash code method, Scott?
I think for something very specific.
Yeah.
But I can't remember.
When
Something about comparing.
yeah, when you need to use it, you can learn that. We're not going to need it for what we're learning here. Okay. All right, so let's look at the toString method here. I thought I had an example of inheritance. Maybe I have a chapter 10 demo, or maybe I talked too much and we never got to it. We can we don't need this example anymore. Okay. I swear. Well, here's one that's inheriting. I never got around to. Oh, right, because we just used the iComparable interface here, but we didn't create an extended class. But here we are creating. I don't think I had time to go over this, but we have a class in here as well called SumClass, and it extends the iLikeDogs class. Or no, this is using the interface iLikeDogs. So the I is for interface. Interface like dogs. Okay, and so let's extend our board game class. Or create a class that extends board game. So we want, let's do, so it's usually something more specific. Let's create a file here, and we'll call it children's board game. .cs. Okay, and since we're putting in a separate file, we need to give it the same namespace so we can connect all that together. I'm just going to copy this code so we can adjust it. Now remind myself why. Oh, we're talking about the toString method. Okay, so we'll extend this later. Because we'll need it for the next part. But we want to look at the toString method. Okay. Oh, I swear we did an override somewhere in here. But I'm not seeing it. Oh, you know what? I probably didn't give it a name. That puts it in the unnamed folder. Okay. Nope, these are all too old. Wow. Apparently I can't remember that. Yeah, it's not here. We did not do that here. Okay, well. I guess the only other one is I might have copied this before and then on accident, so if we go back to the original one, I think it'll have it. It's hard to find time to go back and organize this stuff, so sorry about that. Okay, so let's check this demo. It really should say chapter 10 for whatever we're doing, but okay. La-da-da. I don't think, I swear we typed, we did override. Okay. Anyway. Okay, extending classes. We need to look at overriding. We already, I swear we talked. You know what? I'll go back and look at the video and figure out where that went. Okay. So to override something, it needs to be, in the way they're doing it here, you need to set it as the member as virtual, which means you're allowing it to be overridden in the children or subclasses. All of its descendants. So let's set, well, in the object class, I think all the methods, or at least all the methods listed in this chapter are virtual, so we don't need to worry about that. So we want to make sure we're in the board game class. Okay, and then we'll just add a method here after the constructor. So we have two constructors. And here's our other methods. We're going to do, I think the signature might have to be the same. Let's see if it, okay, so in the base class, you got to put virtual. In the subclass, okay, in here they're using the new keyword. Let's go, okay, here we go. Wow, it's right in the slide. Okay, so it says, you know, by default it returns a string that holds the class name. So if we try to print out one of the board games we've created, the object, you know, so here we're creating a new board game. That's an array. We're creating a new board game array, but down in here, right here, we're creating a bunch of board game objects. Or maybe we're just creating one. Is this a for loop? Yeah. Instead of this for loop, we're taking in the input and using it to create a board game object. And so, and we're storing the reference in the array, right? So the array is just full of object references. So we can access one of those. So here we're printing out this string that we built. So let's just check the output first and then we'll... Okay, so it's printing out all this stuff. Down here it's printing out I like hounds. Let's do it right at the beginning. Let's look for our first right line. Oops. Okay. So we're going to do it before it starts asking us for input, so we don't have to put input. So before that, we are just going to try... Oh, but no board games have been created, so we can't do it here. We'll just print out the board game after it, the reference right after we create it. So right down here, we'll do console. So this is inside the for loop. So the first part is asking the user, provide the input. And so over here, you know, I put 111 for everything. And so it's showing those values. But I have to specifically reference the properties using the reference stored in the array. So I'll go console dot, And so if I want to print out and whatever, print out the object, I can use the reference. We'll do board games array. We'll grab the index of the current board game, the value of the index that it's assigning the object to. And we can use the toString method. Actually, it'll call it when you just run this. Let's make sure. Oops, I forgot right line. That's important. And I'm trying to rush, so I forgot my semicolon here. Okay. So every time I enter in the information, it should print out the object. All right, so here is what it prints out. Board game sorter.boardgame. So within the namespace of board game sorter, that's what we named named the namespace. And so everything that's part of this that we want to connect together, boardgame.cs, also is part of the same namespace. So that's telling you how it's getting to it, and it's telling you the type of this object is board game. So if we want to manipulate that class, we know it's called board game. We can find the file for that and make changes. Okay, but this isn't that useful. I don't know, for user output. Maybe for debugging it's useful, but for user output, they don't care what the class is called. So we can change the toString method to change what the output is when they try to print out the object. All right, so inside of the board, so I've kind of labeled my sections here to be more organized. Saves me a lot of time, and so that you guys can kind of read this more easily read this. All right, so we want to put in the override for the toString method. So it's public override string. Public because we want to be able to access it outside the class. Override because we are adding we're changing the way toString works from the object class, which is the ancestor of this class. So we can imagine here is the board game class. It inherits the members of the object class, and then everything extended off of that inherits the members of its ancestors. If that's fuzzy, take a look at the previous video. Okay, so it's override. So we are going to give our own code for doing this. Okay, and then string. This is our return type. We want it to give a string, and so that we can right line it. We use the name so it knows what it's doing. And I don't think it has. Does it have? I think it has the object. Nope, it has no arguments. It doesn't need them. All right, and then we just have to return whatever we want in the toString. And you could still return the, what do they have here? The get. You can just call the get type function of the object class to still get the type. But let's just print out the information about the board game in our method here. All right, so we'll return name. Well, we already have this in the loop, so. All right, game name, players, and rating. Here's our string. So we can save a little time by putting that in there. Okay. We need to remove the references to the array. It's not inside of the class. It doesn't know the array exists. We did that on purpose. Everything you do is on purpose in programming. You don't ever do anything I don't know what I'm trying to say here. You wouldn't just change things that you aren't going to use, or mess with things that you aren't going to use. You want to have purpose in everything you do. Okay, for this anyway. So we'll just print out the name, and then here again we don't need the reference to the array. Because this method is inside the object, it has implicit access to the properties. So we could put this dot name, but I think it should assume that we're talking about the name property in here, as long as nothing else is called name. Here we can call this players, and here we can call this rating, and don't forget your semicolon. Make sure it compiles. Hey, it compiled the first time. And so we're not using the method yet, so let's go back here. And inside of here, you know, this is messy inside of here. So what we can do is just do output plus equals. We don't want to get the reference. We want to get the toString, so we can do, we'll keep this game number for the counter because that's not stored anywhere in the class or inside of the object. But we did tell it to include the name, players, and rating, so we don't need that in our string anymore. Right, all we have to do is put inside of here, we put a new line and we just have to put a board. So we do have access to the array within this scope. So board games, that's the name of the array, x, because we're in a for loop, so it's going to pull out each value for x. We can use that as the reference, and we can just call the toString method here, and that'll return a string we can use. And it is a method, so don't forget your parentheses. Alright. And let's see how that changes things. Might have forgot something. Nope. Okay. So let's go checkers, 1 player, rating of 1, chess, 1, 1, and Mancala, 23, 23. And so now this is inside of the main. It's more concise because we can use the toString method to print out the object however we want. And so if we want to print out all the properties, we can do that. If you only want to print out some of the properties, all you have to do is go to the board game class and find your toString method and change what it returns. Okay, and let's shrink this down a bit. So I know it's hard to read this stuff when it's wrapped around. So if you're watching this or you go back and check things, make sure you're paying attention to the line numbers. If a line does not have a number, it's part of the previous line. Okay, so let's say we only want to print the name. We don't care about the players and the rating. You can also create your own methods, which is probably a better idea. So we can create a method called, we don't need override because we're creating a new method. Got to give it a unique name. We'll say, we'll call it BG stats. Okay, and no, we'll call it BG print stats. All right. And we want it to return a string so that we can call this method if we want to print out this format. And for this one, maybe we want it to print out everything. We can have another one that'll print out only the name and rating, maybe. So we'll call it BG print name rating. All right, make sure. So in this case, we don't want the players included. Why would I do this? Well, just as an example, right? You can use this for whatever you need to get out of it. And so now if we want to change it to only print out the name and the number of players, or name and rating, whatever we did here, we just call this method. And since we have a for loop that goes through and prints them all, instead of calling the toString method, we can just put in our new method, BG print name rating. So checkers 1 1 chess 1 1 and Kala 1 1. And there it's only going to print the name and rating. So you can create your own method for our output type things. Instead of having, if you have like a common format that you need things to be in, or you can have multiple formats by adding them as methods, or you could just do it in the main. But again, if you're doing it over and over again, in this case we were doing it one time in a for loop, but if we had another for loop that wanted to print them out later, we would have to copy the code down. But instead of doing that, you may want to make it a method in the class, so that way if you want to change what's printing out, you don't have to go and find all those for loops in this case. So in the base object class, we have a few different methods. The toString method, I like to showing this one is useful so you can understand if you just want to print out an object, you can do that. Now I want to see if let's say we just put, instead of the method of toString, I want to see what it does if we just reference the object. Okay, so checkers 1 1 chess 1 1 and Kala 1 1. And so here we've made it even more concise. Since we're putting this in a string, it just assumes we're going to use the toString method, and so it'll grab whatever code you have in there and use it. So you can make it even more concise. All right, so that is that object method. Okay, let's move on because we need to talk about abstract classes and I keep wanting to say inheritance. Interfaces. Okay, there are some slides in here about creating different types of constructors. We already talked about that before. because I had assumed this is something you had learned in the previous class, since it's basically the first thing you should learn in object-oriented type programming. Gotta make sure this is what happens when I teach for too long. Everything starts to run out of battery. No one's talking in chat anyway, but I just want to make sure if you do, you're there. Okay. So, the people that are in here still watching, you are, I can tell you're dedicated to this, or maybe you're AFK. All right. Okay, so let's look at abstract classes, because this has to do with inheritance and polymorphism. Okay, so it says abstract class is a class that is used to instantiate. Okay, this is confusing. This is what an abstract class isn't. A class that is used to instantiate objects is a concrete class. So conference, board game, not I like dogs, but I don't remember what it was called, but board games and conference, those are concrete classes. We can, from that class, create board game objects and conference objects. Okay, a class that you create only to extend from, but you can't make objects from it, so you can't instantiate it. That is what an abstract class is. All right. So, when you're creating an abstract class, you use the keyword abstract, all right, and it can contain methods, all right, but it only contains the method signatures, virtual method signatures. So that is the access modifier, the return type, the parameters, and the name. Okay. So methods in an abstract. So you can add abstract methods into an abstract class. It says methods are not required. Okay. So maybe you just want properties. When would you use this? Okay, so we can look back at our diagram where we had organisms, and then from organisms we have bacteria, animals, and viruses. And from viruses we had a couple different classes here. And then from bacteria we don't have any classes yet that are extending that. And from animal we are extending to the dog class and the cat class. Okay. Don't be confused on here about the where it says base class and derived class and extended class. That's just to help you see the terminology. So, for example, the COVID-19 corona class is a derived class of virus. It is an extended class of virus. Virus is the base class of COVID-19 corona. Okay, I just didn't label everything that way because it's within the context of what you're looking at. So the fact that dog and cat have two different labels on them, these, at least the way we're using these terms, they're interchangeable. There may be some kind of very specific difference. If we encounter that, we'll figure it out. Just take a quick Google to figure that out. For now, it doesn't matter. You just need to understand what a base class is, extended class, and now we're introducing abstract classes. So, and we're trying to figure out why we would use this. Okay, so an abstract class is used when you want to create a class to extend other classes from, but you don't want to instantiate that class. So for example, in here we have an organism class, and we have bacteria, animals, and viruses. In this example, you would never need to instantiate an object from the organism class, because any objects you create are going to have to fall into one of these three classes. So we wouldn't make an organism. We shouldn't allow an organism object to be made. But since bacteria, animals, and viruses share a lot of properties, we can create an abstract class to list the things that they have in common. So that, and we're also requiring the classes that extend from an abstract class to override any methods. So we can control the if people extend this out, if you're collaborating and working on this, and you need everything derived from it to have a certain method, put it in the abstract class, and then whenever anyone tries to extend that out, they'll have to override that method and provide the method signature, and then put in whatever they want it to do. And so we had the example of reproduce as a method, because organisms, they wouldn't exist if they couldn't reproduce. And bacteria, viruses, and animals reproduce in very different ways. Okay, even within animals, there's a lot of weird ways that things reproduce. All right. So okay, creating and using an abstract class. So here's an example, and it looks, I didn't plan this, but they're kind of using the same example, but they're ignoring the upper level. So for this explanation, we're going to be making the animal class the abstract class for this example. So we're going to, what would that look like? So we call it up here abstract class, give it a name. We put a field in there. It looks like they put a field in there. This is a constructor. How do you know this is right here? This is a constructor. You should be able to look at this and immediately tell that it's a constructor. What about it should tell you? Well, the name of the method is the same as the name of the class. That's how it knows it's a constructor. That's how you should know it's a constructor. And you can provide parameters for your constructor, and you can overload the constructor to take different arguments. You just have to provide different parameters. So in this case, they're just making a overloaded constructor. So that means it has a different method signature, and you can assume this has a default constructor, which takes no arguments. But in this case, they overloaded the constructor. The method signature is different because it takes a string, so it takes an argument. You can't use this method unless you provide a string. Okay, and then it just assigns what you passed in to the name field here. Okay. And then here they're creating the property with the get method. Because they sent the field to private, we won't be able to access that outside the class, but by providing a get method for the property here that returns the value, this is how it can pass the value outside of the class. Okay, and then here we are creating a method signature for speak. All right, I don't know if that's a very accurate method that all animals would have. Communicate would probably be better. You know, unless the only animals we have are parrots and humans. Okay, so here's the syntax. I'm trying to decide whether, yeah, we should do an example. I want you to have a demo to look at for sure. It's going to take a lot longer, but I want to do a good job. So, and this is complicated. It's going to take time to understand. So the more we do, the better. Okay, and I don't have any meetings or classes today, so. All right, we want to create a new C# REPL for this, and we'll call it polymorphism abstract classes and interfaces, because that's what we're going to cover. That's what I want to cover today, and we are we were like 3 hours in on this. So remember, you can turn this up to, if you have to watch this later, you can turn this up to 2 times speed if I'm talking too slow. Save yourself a lot of time, and you can definitely skip around in the video. If I had time, I would put timestamps in the comments. That's something maybe I can do over winter break, but that's going to be too late for you guys, so what happened there? Sometimes my touchpad likes to have a mind of its own, and it likes to put folders in the wrong place, and it likes to close things randomly. Okay, what were we calling it? Oh yeah, polymorphism. And polymorphism, any large word that you see, each part has a meaning, so you can break words down to help you understand. Don't be afraid of big words. Okay, so in object-oriented programming, polymorphism is the ability of an object to take on many forms. So what we've talked about so far is, if I have an animal, so in the diagram here, if I have an animal object, I can store it. Well, what did they say here? Let me make sure I'm saying this right. Here we go. Polymorphism. So in here they're describing it as using the same method to indicate different implementations. So we have classes in this example that inherit members from their ancestors. So an animal can do everything an organism can do, but a virus may not be able to do everything an animal could do because it doesn't inherit from that. And so we can consider an animal an organism, and we can have a cat. We can consider that an animal and an organism. Okay. Polymorphism abstract classes and interfaces demo. Okay. I'll go ahead and post this in chat too. So that, and I might post it in class, but we'll see. Okay. Alright, so we're gonna need, let's follow the example in the slides here. Let's make a animal class that we're gonna want to be abstract. And let me look ahead here. What other classes are they gonna want us to make? They want to have dogs, extend animal, and I guess that's the only one we're going to use for now. We only need one for the example. So we'll have dog.cs. And we're going to make these very simple classes so we can focus on what's happening. Okay, so in animal CS, let's create a namespace here. Animal abstract. Okay. I want to move this into the namespace. Okay, and I'm going to line this up so I don't get confused. Should be in one level, and everything else looks fine. Okay. And we'll need this for each other class. So we have the main class in the main file. We'll have the animal class in the animal file. Hopefully you're understanding why we're organizing this in separate files. Just makes it a lot easier to locate and change things. Okay, we don't need this, but we do need this. So dog will extend animal. All right, let's see if it's mad about any of this. Okay. Oh, I have an extra curly brace in these. Let's get rid of that before it causes a bunch of problems. All right. And we wanted the animal class to be abstract, so that's easy, right? Just put abstract there. I need to move this back. Okay, that goes there. This class is inheriting from animal. And you need to start getting used to identifying where these things are that tell you what they are. Because you can't just look at this and say, oh, you know, what is this? You need to know, you know, this is a class. Oh, and I need to make these public. This is a class. How do we know? Well, that's easy. It's a class. But what is this? Okay, this tells us this is a child of the animal class. And why? What does that do? Gives it access to the members of its parent. All right. Okay, so we got the abstract class. And what did they put in there? They want to go ahead. Oh, we had to speak. That's what we had. So you don't write the code for the method inside of the abstract class. You only put the method signature. And by doing that, it's saying, you know, you will need to override that method. If it's if that is the ancestor of any class, then you need to give it the ability to speak. you get to choose what that means. You don't get to change the return type or the parameters. You get to change the code inside. You can make it do what you want. Okay. So we'll go ahead and add that. Alright. My phone is messing up. So, no one's chatting anyway, so I might check it every once in a while, but I'm just going to turn that off for now. So I'm not actively seeing the chat right now. Okay. It's probably good. I don't need to be distracted right now. Okay. So we want public. We do set the access modifier. So public. Wait, was that just on the class or on the method too? Yes. Public abstract. String is the return type. We know it's abstract, so you have to be to use it. You got to override it. Speak is the name. No parameters. All right. So we've defined that. Make sure it's not mad. Base class is right. We gotta make the class public if we want to access it in the main. Okay. This error is good. It says animal abstract.dog does not implement inherited abstract member the animal.speak. So within the namespace of animal abstract, there's a class of animal, and we need any child class or subclass of the animal class to implement this method. So let's fix it. And again, if you get this and you don't remember, just look at the code, look at the Google it. I'll be doing a lot of Googling in this job. Unless you're omnipotent or omniscient, whichever one means you know everything. Okay. Does not implement inherited abstract member. Okay. Remember, if you end up on Stack Overflow, the first thing you're going to see is the question someone's asking. And so don't start using that code because they're usually providing code that doesn't work. Go down until you find the check mark here, and then okay, blah blah blah. If we read the question, it would say, hey, I'm doing this, here's the error I'm getting, what do I do? And then they're giving, you need to, I don't think this is a good example here. Anyway, but I'm just telling you what the error is. If you can't find the answer on the first link, just keep looking. Actually, the first link for that was probably better than this one. Okay. Yeah, because here's the documentation. Okay, with an example that has the error, and it says just uncomment this to fix the error. And so to fix the error, you need to provide a method that matches the signature in the abstract class. So how do we do that? Well, we can just copy the method signature into the child class, and we have to, make it do something here. In the child class, you don't label it as an abstract method. You want to put override so it knows that you are adding this new thing. Okay, and now it's mad just because it's empty. So we just make it not empty. We can do return bark. Make sure it's happy. Okay. How do we test it? Because there's always 100 extra steps in C#, but they're important steps. In the main method, instead of printing out hello world, we will instantiate a dog object. So we want to create a new variable of type dog. Call the variable pet. We're creating a new object, so we use the new keyword, and we provide the constructor method, and so by default it has the default constructor, so we can use that. It doesn't have any properties, so we can't change any of those here. And instead of printing hello world, we will print pet.speak. And so the string that this returns is what it'll print out, hopefully. Yeah, bark. All right, so that's as simple as abstract classes are. So you need to understand how to create one, how to use one, and why it exists. So we want to give similar classes different abilities. Okay, that's the simplified description. And correct me if I'm wrong, Scott. You use an abstract class to give similar classes different abilities. And then an interface is giving different classes similar abilities. I think it's for tying together, or basically it's forcing you to provide certain methods. Right, but you can't use an abstract class between different classes that aren't related, I think. You can use an interface for non-related classes to do things, I think. Anyway, we're going to talk about interfaces today. So in this case, if you want your children of the abstract class to have the same function or the same method, so for example, we don't want any of these children of the organism class to not have a reproduce function. Okay, everything that's alive has a way to reproduce. All right, not each individual organism, but as you know, every virus, different type of virus has a way to reproduce, yada yada. If it doesn't, then it wouldn't exist, right? Or it wouldn't exist very long. Kind of like, I think mules are born sterile, and I think it's the combination of a horse and a donkey. You're learning agricultural information today. So, I mean, that's a form of life that can't reproduce. But it is the result of reproduction of two different things. That would be a good example of an interface. Okay. Maybe not. Okay. So make sure you understand that, because you'll need it for the assignment anyway. All right, so the interfaces are the other thing we want to talk about. An interface allows a class to inherit from more than one class. All right. I like that the next item on the list here, it says, a difficult concept. Programmers encounter problems when they use it. It kind of, some people consider it a workaround of one of the main principles of object-oriented programming. And maybe you'll see that in seeing how it works. Okay. So, we want each class to only inherit from one other class up to the point where we've looked at. if we, for whatever reason, you do need a class to have abilities from different sources. I'm trying to find the words to describe it simply, and it's just a complicated topic. You'll see in the example. Okay. So all an interface is, it's similar in structure to an abstract class. It's just a list of member definitions. And then if you include it in a class, or you extend using an interface, like we did in, I do have this one, so that's good. But I closed it, so let me pull it up again. In the example for the conference where we had to use iComparable, that was an interface. Someone else created the interface, but we were able to use it, which shows you one of the strengths of object-oriented programming. We can more easily use code from other sources than our, we don't have to write every line of code for everything. You would never be able to get anything done. Someone will find a solution that's accepted as the best solution, and then everyone will use that as the standard until someone finds something better. All right, here it is. No. This one. Look in here. So, we have board game, and here we're extending the interface here, iComparable. Okay, and that required us to include a compare to method. So that gives this class the ability to be compared to other things, and when any other class or method needs to compare this class, if it implements iComparable, then they know you followed the standard of making it comparable, and it will use the code that you provide. So anything that extends this, you're basically promising it's going to have that ability. All right. This makes the after we look at how this affects the diagram, it becomes a lot more complicated because you can extend multiple interfaces. Okay, so what does it look like? So here's an example. Okay, in the code here, public interface iWorkable, and so it's the standard here to put I in front of it so people know it's an interface and not a class. And they're just providing a method here. All right, we'll have to continue on here so I can understand what they're doing. Okay, in an abstract class, not all methods need to be abstract. So let's take a look at that since we have that working here, right? Did I finish what I was doing? Yeah, we made it bark. In animal, let's add another method that isn't abstract and see if that works. Okay, so we just want a public. Return a string, and then we can provide the code here. Let's make it eat, give it the ability to eat, and we can return chomp, 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 chomp. Okay, See if it's mad about that. I might have forgot a piece. Nope. Okay, so now dogs can eat. So in here we have our dog object stored in pet, and we're printing out pet.speak, and we can do, let's concatenate that, and let's do a separate one so it's not confusing. Easier to read. Pet.eat. Let's see what happens when we do that. Alright, so we didn't have to provide the code. This is what we already learned, right? A subclass does not need a method definition if you're just going to use the method from the parent class. So here, remember, dog extends animal. It has a speak method in here, and we had to include that because the class that it's extending from is an abstract class that has this method signature here that says abstract. So it needs, you have to provide this in the subclass. But this one is a fully formed method that this can use, okay? And we don't have to define it again in here. All right, let me check the chat now. Nope, okay. And we're down to, I think, 1 or 2 people watching. All right, so we're thinking about creating an interface. How do we do that? All right, so here we go. Let's take a look at this. And it's nice that they put it all in one area here so you can kind of see it without having to switch files. Okay, so they have an employee that's extending iWorkable. Do they have, oh yeah, an iWorkable is a public interface that we saw back here, and so it has this member here. It should be a method, and I guess it's returning a string. All right. So animal has to provide a definition for work. All right, so here we're just adding it as an abstract method. So that means you'll have to define it in the children class. And so here they have dog. They have dog and cat. Okay, so the dog will have to have a work method, and the cat will have to have a work method because they extend animal, and animal has an abstract method of work. So by setting it up this way, you are, this is all about controlling what goes where, so that there are rules that if everyone follows the rules the same way, we can work together a lot better. You don't have to explain how you did it because it's explained by the code. All right, so they've overridden the work method in each subclass that extends animal. All right. And they have here's the thing. Employee is a base class, okay? It has the iWorkable interface. Animal is a base class that's extended by dog and cat. They also use the iWorkable interface because that's what their parent has. Okay. So what would that look like? This is the important part to help you understand this. What does that look like in a diagram? So I don't want to mess up this diagram, so we'll save it, and then We'll save it as, to make a copy of it, we'll call this interface example diagram. All right, and we'll go ahead and get rid of this. Actually, no, we can use this. All right, I'm going to get rid of this. So you can assume the class is, any class is going to extend the object class. So I'm going to take that off here. You just have to make that assumption. Or you should just know, like, you know, that's a fact. Okay. And we'll get rid of all of these extra classes that we don't need anymore. And, you know, remember the colors here, you know, kind of represent different relations. So there is no connection between the games class and its children and the organism class and its children. Oh yeah, this didn't have a fill color. Fill of white and fill of white. So yeah, I figured out how to do that. Proud of myself. Okay, so here's what we have. We have two classes. And let's move this one over. Let's shrink this down. I don't want to keep scrolling. So grab that. I'll grab these two. Okay, and we can, whoops, shrink this down. All right, and then we'll move these all down so we can show how the interface works. Okay. All right, and let's go back, and we want to take a look at how they are creating an interface. All right. So it's public interface iWorkable, and you put this on the class level in the code. So where's the code at? Here it is. I don't. Do we need this anymore? No. Okay. So you could create a new file. Oh yeah, we have to think of something that we want board games and organisms to be able to do. So what would be a similar method we need for those? So they did iWorkable, which just returns a string from each class saying what it does, I guess. So we can do something similar. So we want, what do we want? We want what is something they can do? I shouldn't have picked something so different. Okay, well let's just go I exist. Okay, so we're making an interface, public interface I exist. Alright, let's make sure they're doing this right. Public interface I exist. Now we put the method signature in there, and so it'll be, what do they call theirs? Work. So we'll call ours exist. So we'll just have it return a string again. We don't need to make that more complicated. But you can return any type. Depends on what you're trying to do with the method, right? So string exist. All right. Let's see if we try to put this interface on our animal class. So we put colon I exist. And actually, to follow along the naming scheme, we're going to call it I existable. Okay. These are able to exist. That is the ability that this interface is going to confer. Okay, did I change it everywhere? I hope. Animal abstract.animal does not implement interface member exist. So if we're going to use the interface, we are promising that we will give a definition to this signature for the exist method. So let's give it a, we can go from the example, we'll make it an abstract method. So for interfaces, you're implying, well, up here it says, where did it say that? Here. In abstract class, not all methods have to be abstract. In an interface, they do. Okay, so you can't define anything in an interface other than the method signature. So the return type, the name. Okay, so an animal, we are doing that, and so let's do public abstract string exist. Okay. So now it says dog, and dog does not have a definition for exist. Since the parent class uses the interface, it has to have that method. So now we have to go through and add that method. And so, the way I'm doing it, I don't have a good reason why I'm using an interface. So, I'll try to make that clear, but the errors are telling me I have to include that. So from that information, I can infer that there's something that needs to do to use the interface, or to allow different objects to use the same methods. All right, so we have to include public override, which does not have two V's. And our type is string, return type, and it's exist. Okay, so for the dog class, we'll have it say bark, bark, I exist. Okay, let's see if that's everything that we need for this to work. All right, no errors. So now in our main, we can have the pet speak, the pet eat, and the pet can exist. Bark, chomp, chomp, bark, bark, I exist. All right. So now you know how to create interfaces and use them. Using them and looking at common interfaces will help you understand why we have them. So at least knowing what they are and how to use them will give you a huge leg up on doing an interview, because this is again something that could be asked of you to explain. And so the simplified version is kind of described in here. An interface right here. An interface is a collection of methods that can be used by any class as long as the class provides a definition to override the interface's abstract definitions. And you notice in the interface we're not specifying that the method is abstract because that's implied. If it's a method defined in an interface, it has to be abstract, which is also said here, right here. In an interface, all methods are abstract, which means you have to override them or provide a definition. Okay. And to follow through, we will add our iExistable to this diagram. So it kind of just floats out here. This is our interface. So if we want board games and organisms and games and their children, organisms and their children to have to implement the methods of the iExistable interface so that it can work with any methods or classes and methods that need those methods to function, then we can have it include that here. If we only need it to go to, maybe we only want dogs and games to exist, we only have to have those classes extend it. Okay, but for this example, we want everything to be able to exist, and we want it to have the same method signature. We will do it this way. Okay, and so this is how it represents. This is how you would think about it. This floats out here, and it's separate. It's not part of the hierarchy. It's just an ability that you can give to any class. Okay, so if we added another class, we could add that interface there. Let's see, is there anything else with that? And you can implement multiple interfaces on the same class. So we'll do C#. I don't think it's going to show that in the slides here, but it might. Let's see if it does. So this is some good information. You cannot instantiate objects from abstract classes or interfaces. Okay, so don't try creating one using the new keyword. It makes no sense. A class can inherit from only one base class. So if you're using classes, all right, every class will only have one parent. Okay, so I can't have a dog inherit the methods or the members of the games class and the organism class. It can only have one parent, and that parent can only have one parent. So it creates a hierarchy. To basically break that rule, we can use interfaces. So if we want dogs and board games to have the same method, we could, but we don't want them to be, because there's a ton of stuff in games that we don't care about these having, right? Animals, dogs, cats, they don't need a number of players, right? So that wouldn't make any sense. But we just want them to have the same method. That's why you would use an interface. Okay. You can implement any number of interfaces. So, if I wanted another one, even though I had such a hard time coming up with the first one, let's just put iComparable in there. So let's look up the syntax for that here. Okay, I thought I Googled it in one of these. No. Okay, I guess not. Let's put implementing multiple interfaces. Okay, can a normal class implement multiple interfaces? Well, it's kind of the point of it. a Java class, and so it's the same in C#, can only extend one parent class. Okay. Interfaces are not classes, and a class can implement more than one interface. And the parent interfaces are declared in a comma-separated list after the implements keyword. That's in Java. And so in C#, I don't think we use the word implements. We just put the colon. So let's double check that syntax. I was looking at this for the syntax. So that's the Java syntax. Implementing multiple interfaces, and it's probably, I'm using the word implementing, which is making it think of Java. So okay, here we go. So they've got examples of two interfaces here, and they're just separating them with a comma. So if we want to include the interface for iComparable, so that way we can sort games, board games, video games, animals, dogs, or cats by any, by whatever we define, then we would just have those extend the iComparable interface. All right, and so maybe I don't care about comparing instances of the animal class, which I think we made an abstract class in here anyway. Animal is an abstract class, so in this case, if we were going to have cats and dogs implement that interface, we don't want to have to put it in both of these. We can just put it in the parent class and it'll be inherited. So put that there. All right, and then you see how these interfaces kind of complicate the structure of. Okay, we'll just give them different colored lines. How's that? Or different looking lines. Let's increase the size of the comparable interface here. When all this stuff stacks, it's hard to manipulate. Okay. There we go. That can go there, and then let's say we also want games to have that ability to compare. We can do that. All right, so this interface has nothing to do with this interface, and they don't have anything to do with either of these class hierarchies. What they do what they are for is to give different classes similar abilities, similar methods, so they can do similar things. Okay, is that complicated enough? That is everything about interfaces and abstract classes that we need to know. All right, you can create an interface when you want derived classes to override every method. Interfaces provide you with a way to exhibit polymorphic behavior. Oh yeah, we were going to look up what polymorphism meant. Because if you know what it means, if you can break it down, it's not just a word that you have to memorize. You will be able to understand it. So. Okay, and I am a huge fan of etymology, which is the study of words from languages. Okay, the word polymorphism comes from the Greek words for many shapes. All right, for example, a polymorphic method, which is mentioning, for example, is a method that can have different shapes, so you can make it do different things, where the shape is regarded as a type or behavior. And so earlier when I had said abstract classes give similar classes the different abilities, or different behaviors is a more accurate or easier to understand way. So an abstract class, if you extend off an abstract class, you're giving those classes a similar ability. If you want two unrelated classes to have similar behaviors, you use an interface. All right. So, and you'll be using those in the assignment. Next time, let's see, when is the due date for that? Right now. Hopefully it's next week and not today. I can move it back if it is. All right, object-oriented programming assignments. This is chapter 10. Exercise 9. Okay, and I have it due the 29th, so you have a week to work on this. Next time I'll probably go over an example that's closer to what the assignment is. So you can compare what you've done so far or what you've turned in to what I've done. I'm not going to do the assignment, but I'll do something similar. Give an example of the things that it's asking you to do. And then I think we'll keep that due date, and then we can move on to the next chapter. Okay, I'm just making sure here. Okay, extension methods you can write to add to any type. The first parameter in an extension method specifies the type extended and must begin with the keyword this. When you write an extension method, it must be stored in a static class. All right. So, what is a static class? So a static class is a class that you don't instantiate objects from, but you can kind of you can access and use the members, so properties and methods, directly by using the class name. All right, so anyway, it shows an example here. So inside of a static class, you include a static method here, and it says you have to use the keyword this, so that way it knows that it is what it's referencing, the actual class. It's kind of like creating a class a static class is like creating an object that you can only ever have one of. So here, let's see what they're doing. So they're creating the method. So this is a static method, and they're only for static classes, even though I think here, I wonder, this class isn't specifically static, and we have a static method in there, so that's might be a lie. Okay. How are they using it? Oh, okay. So in this example, the main class is static. and they have a static method here of add check digit. So to use this, they can, it looks like they're calling it, but it's implying that this field is, let's see, I'm trying to parse this here. Revised account number is account number, so these are local variables here of the static class. And they're using add check digit here. And it's passing in, not seeing how it's getting this into here. Okay. Account number, revised account number. What are they trying to do here? This is the last thing we need to look at. So extension method. Okay. Okay, so I think what this is doing in this case is it's saying the argument is going to be whatever you are using to call the method. So in this case, they're setting account number to 49, and then here they're accessing this method from just this integer, and it's saying if you do that, it'll take the value in here and run it through this method. All right, so where are they getting the 3 from? Oh, they're taking the first number, they're dividing it by 10, because that moves down, so we know 4 is the first number, and then the third number, there's adding them together and modding by 10, so that's why it's 12, which is 0, 1, 2, 3 higher than, well, 12 mod 10 is going to be 3. No, it's 9. 4 plus 9 mod 10 is becoming 3 in this case. Oh, 4 plus 9 isn't 12. I've been talking too much. 4 plus 9 is 13. I might have said that earlier. And so 3 is, so 13 mod 10 is 3. Okay, so that's how they're getting that. All right, so the important thing to understand about this extension method, if you ever encounter it, is if you want to implicitly use the value as an argument in a method here, you have to put this in num in your, you have to include this in your parameters. Okay. And the rest of this we don't need. Okay. So how are we doing on time here? That was a 4-hour video. All right. So I guess I'll see you next week. If you have problems with the assignment, you need to email me. Don't put it off till the last minute. You see how complicated this is. You need to work, if it takes multiple days to work on it a little bit at a time. Have the PowerPoints open, have this video open so you can skip through. The exercises they're vague on purpose. Luckily, these aren't too vague. So let's see which one this is. Maybe I can give you some tips. Chapter 10, exercise 9. We're in chapter 10. Switch over to exercise 9. Here we go. Okay, so how are you going to be using these interfaces and abstract classes? So in your hierarchy of classes, you're going to have salesperson that gets extended by real estate salesperson and Girl Scout. Okay, we don't want objects that are just a salesperson in this program. That's why we're going to make it an abstract class. But Girl Scouts and real estate salespersons should have similar abilities or similar behaviors. You know, selling something, make sale. Use a make sale method 2 or 3 times with each object. Okay, so that's just testing the code. And display the final contents of each object's data fields. Okay, so you could, if you wanted to, use the toString method to simplify that, or you could manually code it to print out each one. I'll leave that up to you, but I think you can probably guess which one's better. Okay, it tells you what fields to include. They're having you create a salesperson constructor that takes in 2 arguments. All right, let me see if we have an example of that in here. This one. Does the board game class have... Yes, we overloaded the board game constructor. So here's the default. Here is a overloaded constructor that takes 3 arguments. So when you create the new board game, you can provide the name, the number of players, and the rating right in the constructor, and it will assign those to the field, so you don't have to do it on multiple lines. That's what that's saying. All right, and what else? Include a method that returns a string that holds the salesperson's full name, the first and last names separated by a space. Okay, so like I showed you, you could use the toString method for that, or you can make your own method. I did both of those in the example. All right, create 2 child classes. Okay, we already know how to extend classes. All right, nothing difficult there. What's a field? You guys know what a field is and properties. Okay, if you want to skip the, because in my examples I'm skipping the step where you create the field. If you define a property, up here the board game class has name, players, and rating. I'm not putting the field there. It will automatically add and manage that for you. Okay. So that's up to you if you want to do that or not. Okay. Okay, and then make it do these things. Add some different things to each of the children class. So a real estate salesperson is paid by commission. It would be hilarious if Girl Scouts got a commission on their cookie sales. I guess that would kind of defeat the purpose of fundraising as a important thing to learn instead of focusing on being driven by greed. Okay. Create an interface named iSellable that contains 2 methods, sales speech and make sale. You need to use that interface. Implement sales speech to display an appropriate 1 or 2 sentence sales speech that the objects of the class could use. And then implement the make sale method to accept an integer dollar value for a house, add the value to the total value sold, and compute the total commission earned. Okay, so this is just the code to put in the method. Should be straightforward. And the Girl Scout one doesn't need to calculate a commission, so you do it just to multiply. I guess they're just keeping track of the number of cookies sold. What does it say for the properties? Data fields. Where is this at? This is like the overview. Down here it says contains fields for total value sold in dollars. That's for a real estate person. Girl Scout just keeps track of boxes of cookies sold. Okay. Anyway, parsing this and trying to figure out what it's asking, that's part of the problem, or that's part of the skill of developing, is trying to identify what the problem is and create a solution. Okay. In this case, you're really just practicing trying to understand what they're asking and just basically redoing what I did in the examples for practice, because repetition unfortunately does help, even though it can be boring. This is a skill. You can't read a book and learn how to ride a bike as easily as if someone shows you or you go out and actually do it. Okay, I'm going to end the video now and get something to eat. Have a good day, and I'll see you guys next week. Do contact